Let's take a look at electronegativity and bonding. So, a review of the definition of electronegativity. It's the measure of an atom's ability to attract a bonding pair of electrons. On this periodic table here, you can see the relative values for electronegativity. Fluorine is the most electronegative element, and cesium is the least. As you go down a group, electronegativity decreases. As you go from left to right across a period, electronegativity increases. So what effect does electronegativity have on bonding? If the electronegativity values differ by 0.4 units or less, we call it a non-polar covalent bond. So an example would be Cl2, the chlorine molecule. It's formed by two atoms of chlorine, the same electronegativity values, so it's a non-polar molecule. If the electronegativity values differ by about 0.4 to 1.7 units, then it's a polar covalent bond. And if the electronegativity values differ by greater than 1.7 units, we call it an ionic bond. Next, we look at polar covalent bonds. Polar covalent bonds are formed by unequal sharing of electrons in a bond. Polar covalent bonds have a slightly positive end and a slightly negative end. The word polar means that something has a slightly positive end and a slightly negative end. Here's some examples. The hydrogen to chlorine bond. The difference in electronegativity between these two atoms is greater than 0.4 units, so we have a polar covalent bond. We say that the chlorine is the little bit negative and the hydrogen is a little bit positive. Here's another example. We have the carbon to fluorine bond. The difference in electronegativity between these two atoms is greater than 0.4 units. So the fluorine atom is a little bit negative because it's the most electronegative atom, and the carbon becomes a little bit positive. So overall we have a polar covalent bond. Polar bonds within molecules can result in a polar molecule, and that's what we'll look at next.